All right, welcome to the deep dive. Today, we're going to tackle a really big one. We're talking about the current state of AI research, where it's all headed, and the kind of impact it's having on everything.
Yeah, it's a lot to unpack.
It really is. So, you shared this incredibly detailed report with me. It's the one put together for the AAAI 2025 presidential panel. And let me tell you, it is comprehensive.
Oh,
But we've gone through it all.
yeah.
We've really tried to pull out the absolute key insights for our listeners. So think of this as your express lane, right? To understanding what's happening right now at the absolute cutting edge of AI research. Why it matters, why this is all a game changer. And, some of those really fundamental questions it raises about where we're going as a society.
Exactly. And we're going to do all of that without getting bogged down in all the technical jargon.
Right. No algorithms here. Well, maybe a few. But our mission here is to really unpack the core trends. What are people seeing? What are people, kind of worried about? We're going to look at some surprising points of view, straight from the AI researchers themselves. And we'll highlight those big questions that are really shaping the future of AI. And for our listeners, the learner out there, we know you value gaining knowledge quickly, thoroughly, and we're all about those aha moments, right? Where everything clicks.
Yeah, we're looking for those connections, those insights that give you that deeper understanding of the big picture.
And the basis for our deep dive today is this report, the AAI 2025 Pre-Panel Report Digital 3.7.25.pdf, which, sounds very technical.
It does.
But actually, it covers a really broad range of topics. We're talking about, how AI reasons, how it establishes facts, the ethics involved in embodied AI, how this all connects to our own brains and how we think. We're talking about the hardware AI relies on, how it can be applied to create positive change and really even fuel scientific breakthroughs. We're going all the way to that big concept of artificial general intelligence.
And the report also doesn't shy away from some of the more nuanced aspects, like the gap between how the public perceives AI and the actual reality of where the technology is, the different ways researchers are approaching AI, the absolute necessity of collaboration between different fields, and, even how universities are figuring out their place in this field that's increasingly dominated by big tech. And to top it all off, this report integrates findings from a survey of 475 actual AI researchers.
So we're really getting a sense of what the experts on the ground, the people working on this every day, what are they thinking? What are their concerns? And one of the things that jumps out right away, and the report really hammers this home, is that AI isn't just this purely technical field anymore.
Right. It's way beyond that.
It really is. It's become so embedded in our lives, in everything we do, that it's really turned into this, what they call a socio-technical field.
A very important distinction.
So to really understand AI, to guide its development in a responsible way, you absolutely need collaboration between not just the computer scientists, the AI researchers, but experts from all sorts of other fields like psychology, sociology, philosophy, economics, you name it.
And this isn't just some theoretical ideal. The survey found that a whopping 95% of the AI researchers who responded are interested in this kind of multidisciplinary research.
95%, that's huge.
It is. It really highlights how the impact of AI reaches far beyond just the code and algorithms.
Yeah, that makes a lot of sense. But I am curious, with so many different fields involved, are there any, practical hurdles in making those kinds of collaborations work smoothly? I mean, are the philosophers talking to the computer scientists effectively? Or are there conflicting priorities that need to be kind of sorted out?
You've hit on a really important point. The report itself doesn't really dive into the specifics of how those collaborations are actually playing out or the challenges they might face.
Right.
But it definitely suggests that bridging those gaps between disciplines, differences in terminology, how they approach research, even fundamental assumptions about what intelligence is, this is an ongoing process. And it's a key area where the AI research community itself needs to continue to develop and evolve.
Because if we don't get that interdisciplinary understanding right, then we risk developing these powerful technologies without fully grasping what they might actually mean for society. And, speaking of understanding consequences, the report highlights this really tricky issue of evaluating AI that exhibits what they call emergent behaviors. And this is where it gets really interesting. Because, as AI systems move away from simply following instructions, do this, do that, and they start developing these unexpected capabilities through these like complex interactions, suddenly the need for really robust evaluation becomes paramount.
Absolutely.
So we need these really well-designed benchmarks, right? Sound testing methodologies, reliable ways to draw conclusions from all those computational experiments. So how do you even begin to, reliably test something that's essentially surprising even as creators?
That is the million-dollar question.
Right.
Right.
With traditional software testing, you rely on like predictable inputs and outputs.
Right.
But with emergent behaviors, you need evaluation methods that can really probe the boundaries of what this AI can do, things its designers never even thought of.
Right. And that raises this huge challenge of how do we design benchmarks that are broad enough to capture those unexpected capabilities, those things that might emerge, while still being rigorous, scientifically sound, and allowing us to make meaningful comparisons between different AI systems.
Right.
The report suggests that we need to move towards more dynamic evaluation frameworks,
Right.
ones that can adapt as AI continues to evolve.
So it sounds like we're moving away from just checking off a list of, predefined functions
Exactly.
and moving towards trying to understand like the inherent tendencies of these systems, their potential. What are they actually capable of, even if we didn't specifically program it in?
It's about moving beyond just the what to the why and the how.
And, this actually ties into another challenge the report brings up.
Yeah.
The strain on the traditional peer review system. Because the sheer volume of AI research, how fast it's all moving, is putting immense pressure on that system. And what we're seeing is that immediate release of research papers, often before they've even gone through peer review, has become pretty common.
It's a fire hose of information.
It really is.
And, there are definitely pros and cons to this. On the one hand, it does speed up the sharing of new ideas,
Right.
which is fantastic for pushing the field forward. But as you mentioned, it also means there's less filtering.
Right.
It could lead to the rapid spread of research that hasn't been thoroughly vetted. So the learner, that puts a lot of responsibility on you to really figure out what's reliable and what's not. The report doesn't give an easy answer here, but it definitely stresses the need for both researchers and the public to develop a more critical eye, to look at these findings, these new AI breakthroughs, with a healthy dose of skepticism.
And as if navigating this flood of research wasn't tricky enough, you've also got to deal with the often conflicting narratives you see about AI in the media, both traditional and social media. One day AI is going to steal all our jobs, the next day it's going to solve all our problems.
And these conflicting narratives, this blurring of the lines between what AI can actually do and what people perceive it can do, this all happens within a context of intense global competition.
Right.
Companies and countries are racing to be the leader in AI, and this rivalry could have big consequences. It could affect access to research, the kind of infrastructure that gets built. It could even impact international cooperation on how we govern AI. The report really underlines the urgent need for global collaboration in AI research and innovation. If this race gets too cutthroat, it could actually harm the open exchange of ideas that's so vital for developing AI in a responsible and beneficial way for everyone.
Absolutely. All right, let's zoom in a bit now and dive into one specific area, AI reasoning. Historically, the report reminds us, reasoning has been considered like a core characteristic of human intelligence. It's how we derive new information from what we already know. And when we use proper formal logic, that new information is guaranteed to be correct. It's like solving a logic puzzle.
Exactly.
If you follow the rules, you're going to get to the right answer. And AI research has actually developed all these different techniques for automated reasoning over the years. You've got things like SAT, SMT, constraint solvers, which are different ways to find solutions to logical problems. And you have probabilistic graphical models, which help AI reason under conditions of uncertainty, where things aren't black and white. And these aren't just abstract ideas.
No, they're not.
This is the stuff that powers real-world applications, like making sure software is correct, optimizing complex operations, how do you get a package from point A to point B in the most efficient way, how to allocate resources effectively.
Exactly. It's the backbone of a lot of really critical systems.
But then along came large language models, the LLMs. And suddenly they're showing this impressive ability to perform what seems like reasoning.
Right.
Just by being trained on massive amounts of text data.
Just feed it all the text you can find.
Exactly.
It's amazing how much they can pick up.
But the key difference, and the report makes this really clear, is that this kind of reasoning doesn't have that guaranteed correctness that you see with formal logic.
Right.
It's more like they're really good at sounding convincing, even if the logic behind it isn't always, perfectly sound.
He can be very persuasive.
Exactly. And it's interesting because the Free AI Community Survey reveals something really telling about how AI researchers think about reasoning. A large majority, like 77.5%, believe that reasoning involves incorporating knowledge, and 72.5% think it should be able to provide explanations, show your work.
Right, be transparent.
But only 37.4% actually prioritize guaranteed correctness as a key feature of AI reasoning.
That's telling.
It really is. And it reflects this current fascination with LLMs despite those limitations in terms of reliability.
It seems like the AI community right now is more impressed by the fluency and the breadth of what LLMs can reason about than whether it's always, logically airtight.
So there's a bit of a trade-off happening. We've got this amazing plausible reasoning, but it's not always spot on. But the report also notes a growing recognition, especially when you're talking about those really critical applications like self-driving cars or AI that's helping with medical diagnoses, life or death stuff. There's a real need to bring more rigor back into how LLMs reason.
Right. We can't just have them being persuasive. They have to be right.
Exactly. And that's where you get research into things like large reasoning models and those neurosymbolic approaches, which combine the pattern recognition of neural networks with the logical precision of symbolic AI. That's like trying to have your cake and eat it too.
The best of both worlds. And it's interesting, the community strongly agrees that focusing reasoning research on either mimicking human-level capabilities or tailoring it to very specific domains, that's seen as very valuable. 88.6% of those surveyed agree with that.
Wow.
And there's also a strong belief that integrating learning and reasoning is crucial. 76.9% support that.
So not just, learning patterns from data, but actually using that to make logical deductions.
Exactly. And making these AI systems explainable and verifiable, 71.7% prioritize that.
Transparency is key.
Absolutely. And one more really interesting finding, 61.8% estimate that we're going to need at least 50% symbolic AI techniques to really get to human-level reasoning.
Wow. So even with all the excitement around LLMs, those core concepts of symbolic AI, that rule-based logic, are still seen as absolutely crucial for building truly robust AI.
It's like we took this detour with LLMs, discovered this amazing language capability, but now we need to loop back and integrate that with those more established, rigorous reasoning techniques.
It's like building a bridge between two powerful approaches. So, moving on from reasoning, the report spends a lot of time on another critical area, factuality and trustworthiness. And this is huge because improving the ability of AI systems, especially those LLMs we were just talking about, to be factually accurate is considered like the single biggest challenge in AI research today. How do you make sure these incredibly articulate AIs are actually telling the truth?
It's a fundamental problem.
If an AI is confidently spouting falsehoods, how can you trust it with anything important? And trustworthiness, as the report explains, it goes beyond just getting the facts straight.
Right, it's bigger than that.
It's about being understandable to humans, so we can follow the logic. It's about being robust, not breaking down when things get a little messy. And it's about aligning with our values, not just giving us technically correct answers, but answers that make sense in a human, ethical context.
It's about building AI we can actually rely on in all those different dimensions.
And the report actually outlines several techniques researchers are using to try to improve factuality. You've got things like retrieval augmented generation or RAG, which is like giving the AI a quick peek at a reliable encyclopedia before it answers. Make sure you're grounding your response in something factual. And then there's fine-tuning the models on carefully curated, high-quality data. Garbage in, garbage out.
Right. If you train it on bad data, you're going to get bad results.
Exactly. And then there's chain of thought prompting, which encourages the AI to break down complex questions into smaller steps and kind of fact check itself along the way.
It's about making the reasoning process more transparent and hopefully more accurate.
And then there's the issue of making these models more understandable, which is also key for trustworthiness. And researchers are trying all sorts of things, breaking down the complex inner workings of these neural networks into more digestible pieces, understanding how the AI actually represents concepts internally, using that chain of thought prompting to get the AI to explain its reasoning step by step, even getting the AI to say, hey, I'm not really sure about this when it's uncertain, It's all about opening up that black box.
And the AI community really gets this. Over 75% of those surveyed said that factuality and trustworthiness are directly relevant to their research. And they brought up some really important nuances. For example, AI needs to be able to understand and present different sides of an issue.
Right, not just give a one-sided answer.
Exactly. And trustworthiness, what's trustworthy in one context might not be in another. And transparency, it has to go beyond just the models themselves. We need to know where the training data came from, how reliable it is. We need that multi-source verification.
So it's a very holistic view of trustworthiness. But here's the kicker. Despite all this research, all these different approaches, the report includes this really sobering statistic. Even the top-performing LLMs, the ones everyone is raving about, are only answering less than half of simple factual questions correctly.
That's a reality check.
It is.
It really highlights the gap between how impressive these models sound and how reliable their knowledge actually is.
So yeah, they can write you a poem or summarize a complex topic, but when it comes to basic facts, they're still tripping up more than half the time.
And that has huge implications for anything you might use them for, from getting quick answers to making important decisions.
Absolutely. So let's shift gears a bit and talk about AI agents. The report takes us back to the field of multi-agent systems, which really took off in the late 90s, early 2000s. The whole focus was on building AI agents that could interact with each other, kind of like a society of AIs.
Right. And game theory became really influential in this area, looking at how these agents could participate in auctions, negotiate, form teams. It was all about these autonomous entities working together.
And it's interesting because while we haven't really seen those massive, large-scale multi-agent applications, like the ones they envisioned back then, the report points out that those individual dialogue agents that we use every day, like Alexa and Siri, those trace their roots back to this research.
It's a good example of how fundamental research can lead to unexpected applications down the line.
Absolutely. And within multi-agent systems, you have this area called multi-agent reinforcement learning, or MARL, which has become really significant. But the report notes that it seems to lack a clear direction right now. What is it really for? What are the big applications? It's a powerful set of tools looking for the right problem.
It needs that killer app.
Exactly.
Yeah.
But the emergence of LLMs has really brought new energy to this idea of AI agents, what they're calling agentic AI. It's about combining those generative powers of LLMs with the ability to act autonomously.
Right. So now the agent can not only generate language, but also use it to plan, to solve problems, to interact with the world in a more sophisticated way.
And we're seeing a lot of startups trying to capitalize on this, trying to build commercial applications around these LLM-empowered agents.
But there's a cautionary note here. The report reminds us that those really ambitious goals of multi-agent systems from 30 years ago, building those truly autonomous systems that can reason over long periods and coordinate complex activities, those haven't been fully achieved.
Right.
And it's not entirely clear how much this new wave of agent activity is building on the lessons learned from those earlier efforts. Are we just tacking on agency to LLMs, or are we really thinking about how multiple agents could collaborate effectively?
It's about smart collaboration, not just bolting things together.
Exactly.
All right, let's talk about AI evaluation, because the report emphasizes that evaluating these systems, it's a whole different ballgame than traditional software testing.
Much more complex.
Much more complex. They're so general, so complex, they adapt, they learn. You can't just run a bunch of predefined tests and call it a day.
Right.
It's like you're trying to assess a living organism, not a static piece of code.
It's constantly evolving.
And right now, evaluation tends to focus on those benchmark-driven tests. How well does this model generate text? How realistic are the images it creates? But the report argues that we need to pay more attention to other crucial factors, like usability. How easy is this AI for people to actually use? Transparency. Do we understand why it's doing what it's doing? And ethics. Is it behaving in a way that aligns with our values?
Right. It's not just about what it can do, but how it does it and what the consequences are.
Exactly. And looking ahead, the report says that AI evaluation needs to consider all these different dimensions. Of course, you have capability. Can it do the task? But usability is just as important. Can people actually use it effectively? And that includes transparency, so we understand why it's making the choices it's making, and directability, so we can control its behavior and make sure it aligns with our goals.
And ultimately, if this AI is designed to work with humans, then the evaluation needs to look at whether it actually improves the combined performance of the human and the AI working together.
So it's not just about how smart the AI is on its own, but how well it can collaborate with us. And the AI community seems to get this. 75% of those surveyed agree that the lack of rigor in how we evaluate AI is actually holding back progress in the field.
It's a bottleneck.
If we can't assess these systems properly, how do we know if we're moving in the right direction?
And the report lays out some key challenges here. We need to figure out how to monitor these systems once they're out in the real world, how to evaluate the safety of those more autonomous, agentic AIs. How do we know they won't go rogue? We need to make these models more transparent so we can understand their decisions.
Right.
And we need to develop methods that really focus on that human-AI interaction.
It sounds like we need a whole new toolkit for evaluating these increasingly complex AI systems. All right, let's move on to another fascinating area. Embodied AI. This is all about the idea that real intelligence emerges from the interaction of a physical body with the real world.
It's about having a body, having sensors, actuators, and being able to act and be acted upon by the environment.
So instead of just having AI learn from data in a computer, embodied AI uses robots as a key platform.
It's learning by doing, by interacting with the world.
And the idea is that these embodied agents, they can learn things like common sense and develop causal models, understanding cause and effect in a way that just crunching data can't really replicate.
Think about it like this. Reading about riding a bike is very different from actually getting on a bike and falling a few times. That's where the real learning happens.
Exactly. And the report notes some interesting trends in embodied AI. We're seeing robots learning through reinforcement learning, lots of trial and error, both in simulations and in the real world. And there's a lot of work happening in adapting LLMs to help with robot planning. So you can give the robot a high-level instruction, and you can figure out how to actually do that in a physical environment.
It's like giving it a goal and letting it figure out the steps.
And the AI community is really engaged with this. 74% of those surveyed find embodied AI at least somewhat relevant to their research. 75% agree it's important for the future of AI. And 72% believe that robotics is either useful or essential for embodied AI research. So there's a strong belief that this more grounded physical approach is a valuable path towards building more intelligent systems.
It's about recognizing that intelligence isn't just about information processing. It's also about action, perception, interaction with the world.
And this actually connects to another really interesting relationship, AI and cognitive science. The report talks about this growing recognition that these two fields have a lot to offer each other.
It's a two-way street.
By studying how human and animal brains actually work, how we learn and reason so effectively, we can get insights to build better AI systems. And conversely, advancements in AI can help us understand our own minds better.
It's like two explorers sharing maps and compasses.
And the report highlights some areas where these two fields really intersect, like human-like learning and reasoning, how we learn so much from so little data, and building more comprehensive formal ontologies, ways to represent knowledge that align with how humans understand concepts, and even developing better benchmarks to test the social capabilities of AI, how well it can understand and interact with humans.
And the survey shows that a lot of AI researchers are already drawing inspiration from cognitive science. 82% said they're influenced by research in areas like psychology, neuroscience, linguistics. So there's a real appetite to learn from how natural intelligence works.
It's like saying, hey, evolution has already solved a lot of the hard problems of intelligence. Let's see what we can learn from that. Right, now we can't talk about AI without talking about the hardware. And the report makes it clear that there's this really tight relationship between AI algorithms and the physical hardware that runs them. They evolve together.
It's a coevolution.
And the report points to things like model compression, finding ways to make those AI models smaller so they can run on less powerful hardware. And sparsity, identifying and pruning away those less important connections in a neural network to reduce the computational load. And even using AI itself to design better systems and hardware. So AI is building the tools to build even more powerful AI.
It's a feedback loop.
And the community agrees. 75% said that the coevolution of hardware and AI is very important or absolutely critical. And 61% believe that progress in AI algorithms is either closely linked to or inseparable from advances in hardware.
They go hand in hand.
But at the same time, there's also support for developing hardware-agnostic abstractions, so researchers can focus on the algorithms themselves without being limited by the specifics of the hardware.
It's about building AI that can run efficiently on a variety of platforms, so it's more accessible.
So it's about pushing the boundaries of hardware and designing AI in a way that can take advantage of whatever hardware becomes available. Now let's talk about something really important, AI for social good. This is about using AI to tackle some of the world's biggest challenges, particularly for those communities that are most vulnerable and under-resourced.
It's about focusing on areas that have been historically neglected by mainstream AI research.
And the key principles here are ethical development, making sure these solutions are fair, that they benefit society. And collaboration is huge. AI researchers need to work closely with experts in the specific domains they're trying to impact, like healthcare or environmental science. They need to work with policymakers and local communities to make sure the solutions are actually relevant and sustainable.
It's about understanding the context, the needs, and the potential unintended consequences.
But the report also highlights some serious challenges. It's hard to scale these solutions, especially in resource-constrained environments. It's one thing to build a fancy AI tool in a lab, but getting it to work effectively in the real world, where things are messy, that's a whole other challenge.
It's about bridging the gap between theory and practice.
And the survey shows that while a lot of AI researchers are passionate about using their skills for social good, about 81.5% said it's relevant to their research. There are some real obstacles. The biggest one is actually testing the solutions in the field.
Right, getting it out of the lab and seeing how it performs in the real world.
And then there's the challenge of scaling up, making it work for more people, connecting with the right organizations who can actually use these tools, and even just defining the problem in a way that AI can actually address.
It's not just about the tech, it's about the whole ecosystem.
Now, another critical area is sustainability. And the report points out this kind of double-edged sword situation. On the one hand, all this amazing generative AI, it's using a lot of energy and water in those massive data centers. That's a problem. But on the other hand, AI also has this huge potential to advance sustainability across a whole range of sectors.
It can make our energy grids more efficient, help manage water resources, assist with wildlife conservation.
And it can accelerate scientific breakthroughs in areas like material science, leading to more sustainable alternatives for everything we use.
So it's both a contributor to the problem and a potential source of solutions.
And researchers are working on things like figuring out how to manage AI's own environmental footprint, how to make those data centers more sustainable, and how to design more resource-efficient AI systems, smaller models, smarter cooling techniques, even scheduling AI tasks based on when clean energy is available.
It's about using AI to make AI more sustainable.
Exactly. And the community seems a bit divided on whether AI's benefits for sustainability outweigh its harms right now. But there's a strong majority, over 70%, who believe that all this data-intensive AI is having a significant impact on resource consumption.
It's a debate that's going to continue as the field evolves.
Absolutely. So let's move on to another really exciting area. AI for scientific discovery. It's no longer just about helping scientists analyze data. AI is becoming a key player in the entire process of scientific discovery.
It's accelerating the pace of breakthroughs.
It can help generate hypotheses, design experiments, analyze massive data set that would be overwhelming for humans to handle. It's like AI is becoming a scientist's best friend.
And we're seeing amazing examples of this. AlphaFold 2, which revolutionized protein folding, is a prime example.
And then you have these robot scientists that can run experiments and analyze the results with minimal human intervention.
It's automating the scientific process.
And the survey shows that biology is seen as the area where AI will be most useful for discovery. And a whopping 81% believe that AI could contribute to Nobel-worthy scientific discoveries by the 2050s, maybe even sooner. So it's a really exciting time for science. Now let's talk about the elephant in the room, artificial general intelligence, or AGI.
The big one.
The pursuit of human-level general-purpose AI. And the report reminds us that this has been a core goal of AI research since the very beginning, back in 1956. And all these advancements in neural networks have really reignited the debate about whether it's even possible and what it would mean if we actually achieved it.
It's the ultimate ambition for many in the field.
But it's important to note that AGI, it doesn't have a clear definition. There's no agreed-upon test to say, yep, this is AGI. But we are seeing AI systems achieving human-level or even superhuman performance on a growing number of specific tasks.
Right, they're becoming increasingly capable in narrow domains.
But the report also cautions that current AI systems still have some pretty fundamental limitations, especially when it comes to things like complex mathematical reasoning, spatial reasoning, and long-term planning. They're amazing in some ways, but still very limited in others.
It's about recognizing both the progress and the remaining challenges.
And the report outlines some of the key research challenges on the path to AGI, like developing new architectures that go beyond those current transformer models, improving long-term planning and reasoning, building AI systems that have human-like memory and recall.
We need systems that can understand causality, not just correlations, and systems that can reason about counterfactuals. What would have happened if things had gone differently? And of course, there's the challenge of embodiment, getting AI out of the digital world and into the physical world where it can interact with the environment in a more meaningful way.
These are huge hurdles.
They are.
And the community is kind of divided on AGI. Most prioritize developing safe AI over directly pursuing AGI, which makes sense.
Safety first.
But a large majority also believe that if AGI is developed by a private company, it should be publicly owned, because of the potential risks and ethical implications. And most actually oppose halting AGI research altogether, even for safety reasons, suggesting a belief that the potential benefits outweigh the risks.
It's a cautious optimism.
But they're also skeptical that just scaling up current approaches will be enough to get us there.
It might require some fundamentally new breakthroughs.
Now let's talk about the gap between AI perception and reality. The report points out that AI has this long history of hype cycles. The Gartner hype cycle, where expectations get inflated, then there's disillusionment, and eventually things settle down. And we're in another one of those cycles right now with generative AI.
Everyone's talking about it, but do they really understand it?
And the report suggests that a lot of people might be encountering AI for the first time through these generative models. And they might not have the tools to assess whether all the claims being made are actually true. And the way we use the term AI, it's so broad, it gets slapped on everything. It contributes to this problem of overgeneralizing its capabilities.
Right. Everything's suddenly AI, whether it's a sophisticated language model or just a slightly improved chatbot.
And the AI community is well aware of this.
Yeah.
A huge majority, 79%, disagree that the current perception of AI matches reality. And even more concerning, 90% believe that this mismatch is actually hindering research.